Hello, in this video we'll be solving exercise 2.5.7 from Jiří Lebl's notes on Diffy Qs. Viewers should note that this exercise has three parts, A, B, and C, but as I will not be doing C in this video, I've cropped it out. So we're given this ODE here, and the two parts, say like part A, we have to use variation of parameters to find a particular solution to this ODE. And part B asks us to find a particular solution using undetermined coefficients instead. And so, how do we proceed with this? Well, first for part A, we need to use variation of parameters. And so for this, we need to take a brief sidestep and remind ourselves of how variation of parameters works. So when we're doing variation of parameters for finding a particular solution, we want to try to find a particular solution y sub p of the form u1 y1 plus u2 y2, where y1 and y2 are the functions that give the general solution to the associated homogeneous equation. And for us, given our ODE here, the associated homogeneous equation is whatever we get when the right side, we just make it 0. So the left side, we have all the derivatives and all the constant prefactors. On the right side, we have things that only depend on x. If we set that equal to 0, once again, we get the associated homogeneous equation here. And here, so you might notice this u1 and this u2. We choose them to satisfy these two constraints. So we want them to satisfy one, which is that u1 prime y1 plus u2 prime y2 equals 0. And a second condition, which is that u1 prime y1 prime plus u2 prime, y2 prime equals whatever the right side of our original equation was, which in this case was e to the x. And so, once we find y1 and y2, the things that generate the solution to the general solution to the homogeneous equation, and we're able to find u1 and u2 from this system right here, we'll be able to find a particular solution in this form right here by just plugging in u1, y1, u2, and y2. So for our problem, because we need to solve this system, but to solve the system, we need to know what y1 and y2 are. First thing we're going to do is solve the associated homogeneous equation, which again in our case is going to be y double prime minus 2y prime plus y equals 0. Now, using the methods we've already learned thus far, this is not so bad. The characteristic equation is just r squared minus 2r plus 1 equals 0. Or, if we factor the left side, we see that we get r minus 1 squared equals 0. And so what this tells me is that we have a repeated root of 1, and so the general solution, therefore, is y equals c1 e to the x plus C2 x e to the x. And this is the general solution for the homogeneous equation. And I think it's probably good to clarify that here. Because this is not the general solution for our original ODE. And we don't care about that general solution. We just, again, this problem only wants us to find the particular solution here. But I think it's just good to highlight this here. So for the homogeneous equation is, again, y equals c1 e to the x plus c2 x e to the x. And so here we see we're going to take our y1 to be e to the x and our y2 to be x e to the x. Okay, so now that we know y1 and y2, our next step is to solve this system right here. Now we can compute the derivatives of y1 and y2. So y1 prime, that's not so bad. This is e to the x. And y2 prime, if I just do some mental product rule, this derivative is going to be 1 plus x e to the x. And so my system, therefore, is going to be, and let me write this in words, is u1 e to the x plus u2 x e to the x equals 0. And then my second equation up here, this equation will become, after plugging in the derivatives, u1 e to the x plus u2 1 plus x e to the x equals e to the x. Now, by dividing both equations by e to the x, so just dividing throughout here by e to the x, and similarly down here, this gives us an, oh, I forgot the primes, oops. We get u1 prime plus x u2 prime equals 0, and we get that u1 prime plus 1 plus x, and I'm going to go ahead and expand this already, oops, it's a bit too big. u2 prime plus x u2 prime equals 0. Or not 0, sorry, because when we divide the right side by e to the x, we're just going to get 1. So this right side becomes 1. And what we can notice is that we can plug in. So I'm going to call this equation 1 and equation 2. We can plug in 1 into 2 because here we have u1 prime plus x u2 prime, and down here we have u1 prime plus x u2 prime. And when we do this, we get that u2 prime, or rather than 2, after we do this, it just becomes u2 prime equals 1. And so if we solve by integrating, we get that u2 prime is x plus some constant c. Now, for the purposes of variation of parameters, we actually don't care about what the constants are for our u1 and our u2. So because of this, we can, the best thing to do is to just set that constant to be 0. The simplest possible antiderivative. And so then, if we go to the next page, so now we know that u2 is x. So from equation 1, and if we go back right here, this is our equation 1, we can now solve for u1 prime to get that u1 prime is negative x u2 prime. But u2 prime is just 1 because u2 is x. So this is negative x. And therefore, when we integrate, we're going to get that u1 is negative 1/2 x squared. And thus, my particular solution will be y sub p, equals, again, it's u1 y1 plus u2 y2. And plugging in u1, y1, u2, and y2, we get negative 1/2 x squared times y1, which is e to the x. And then u2, if you'll remember, was x right here. So we get plus x. And then our y2, as a reminder, was x e to the x. And so this is negative 1/2 x squared e to the x plus, x squared e to the x, which works out to be 1/2 x squared e to the x. Very nice. Now let's do the same problem, but now with undetermined coefficients. So this is 2.5.7b. And so now we're doing the method of undetermined coefficients. So going back to our ODE, we see that the right side is an exponential. It's e to the x. And so when we're doing undetermined coefficients, the key is to try and guess a particular solution yp that's going to fit the right side. And so here, since the right side of y double prime minus 2y prime plus y equals e to the x is e to the x, a first guess for a particular solution y sub p, well, it makes sense that we should try some constant a times e to the x. If we plug this in, well, y sub p double prime, so we're plugging this in to this ODE here on the left side. So this is going to be y sub p double prime minus 2y sub p prime plus y sub p. The derivatives of y sub p are easy enough. They're always going to be a e to the x. And so we get a e to the x minus 2a e to the x plus a e to the x, which gives us, well, it's not hard to see that this a to the x and this a to the x add up to be 2a e to the x, and that cancels out with this, so it's just 0. But notice that this is not equal to e to the x, which is the right side. And so what this tells me is that choosing my particular solution to be of this form isn't going to work. But that's okay. So this doesn't work, but we can try the next thing. So again, the right side is still e to the x in our equation, but because just doing a constant times e to the x didn't work, now let's see what happens if we do a times x e to the x. Now here we need to compute derivatives, so y sub p prime is going to be a1 plus x e to the x, just a quick product rule. And y sub p double prime will be a, if we do the product rule again, you'll find that you get a times 2 plus x e to the x. And so, if we plug this in, y sub p double prime minus 2y sub p prime minus, or plus y sub p is a 2 plus x e to the x minus 2a 1 plus x e to the x plus a x e to the x. And this, if we factor out a e to the x from all the terms, will give us this 2 plus x. And then here I'm going to distribute the minus 2. So this is minus 2x plus x. And we can see that, okay, 2 and minus 2 cancel. X plus x is 2x, which cancels out with the negative 2x. So this whole term right here becomes 0. And so once again, we get 0. Which is again a problem, because once again, this is not equal to the right side of e to the x. And so now we try we try one more time. So now let's try to guess y sub p equals ax squared e to the x. And in general, this is how it's going to be whenever you have that with undetermined coefficients. Your first guess doesn't work, just multiply it by x to get this. And if this guess doesn't work, multiply by x once again to now try this guess. And so here, y sub p prime will be a, and then doing the product rule, 2x e to the x plus x squared e to the x. We get that this is a e to the x, 2x plus x squared. And y sub p double prime will be a e to the x, 2x plus x squared, plus e to the x, and then this will be 2 plus 2x. And so this simplifies to, factoring out e to the x, 2x plus x squared plus 2 plus 2x, which is a e to the x, x squared plus 4x plus 2. And so now if we plug in y sub p double prime minus 2y sub p prime plus y sub p, this will give me a e to the x, x squared plus 4x plus 2, minus 2 a e to the x, 2x plus x squared, and then plus y sub p, which is ax squared e to the x. And this works out to be x squared plus 4x plus 2 minus, distributing the 2, minus 4x minus 2x squared, and then plus x squared. And so now we just need to be careful here. So x squared and x squared add up to give us 2x squared, which cancels out with this. Nice. 4x cancels out with minus 4x. Good. And all we're left with is 2. So now we have 2a e to the x. And this is great because this we can make equal to e to the x if we make the constants 2a in front equal to 1. In other words, we make a equal to 1/2. And this gives me a particular solution. So just plugging in a back into our guess right here, we have a particular solution y sub p equals 1/2 x squared e to the x. Okay, that's it for this video. If there are any questions, please feel free to leave a comment. Otherwise, I will see you all in the next video.